Hi, everyone. Welcome to my session on application modernization and DevOps best practices using the Cloud Strangler pattern. Hello, my name is Deval Parikh, and I'm a Senior Solutions Architect at AWS. I help customers solve their biggest business challenges by providing strategic guidance and prototyping solutions on AWS Cloud. Let's take a quick look at what we will be covering today. We'll start with defining the problem statement. We'll talk about the challenges associated with monolithic architectures and make a case for moving towards microservices. We will also talk about a peculiar pattern that is commonly used to move from monolith to microservices, and then discuss some anti-patterns in taking this approach. I will quickly show you how to build a Docker container and deploy it on Amazon Elastic Container Service, aka ECS, a native AWS container orchestrator. And then finally, we will look into a DevOps model architecture that integrates well with microservices architecture. So organizations today are looking at moving away from large-scale monolithic architectures and embracing microservices to become nimble and move faster. Some of the challenges with legacy monolith are they are complex systems, and over time, as they grow larger and larger, they become tightly coupled and unmanageable systems that can easily break with new changes. As the complexity of the system grows, the only way to support it may be to scale vertically. And it may not be easy to employ automation pipelines or run them as containers to take advantage of horizontal scalability. So let's take an architectural approach to this problem statement. How do you then break down a legacy monolith application to a microservices architecture? Very often, the answer that you hear is use a Cloud Strangler pattern. A Strangler pattern is a way of migrating your legacy system incrementally by replacing existing functionalities with new microservices in a phased approach. The pattern was coined by legendary Martin Fowler in 2004 after observing the amazing Australian Strangler fig vines. If you have seen these fig vines, they intertwine and grow around to envelop their host tree, eventually killing the host and self-support themselves. To understand this transition from monolith to microservices architecture, let's take a look at some of the anti-patterns of this solution delivery. You see, in a Cloud Strangler pattern, breaking up the work into very, very small, discrete microservices from the very beginning is ill-advised. It's not to say that you shouldn't separate tiers to optimize frequency of change and deployment, but any premature optimization and building in unnecessary complexity isn't the right starting point. Instead, we should aim to shrink and refactor components over a period of time with a focus on continuous improvement. In addition, we must intentionally simplify components so that they can be easily managed by small, independent, autonomous teams. Now, I want to emphasize that much of the best practices that I just talked about stem from fundamental principles of agile development methodology. Let's take a quick look at a typical monolith architecture in your data center today. Assume your monolith is a large-scale application with tightly coupled functions that manage your vendors, your customers, your employees, content, etc. Assume these functions connect to a single database like MySQL database. And let's say you have many clients that connect to this monolith, which in turn may have DAO functions with business logic and connections to retrieve data from the databases or the database. As you add more functionality and wire connectivity between these modules, you increase the complexity of the system and thus your ability to test and deploy new changes. Sometimes things break and you have to roll back with approvals. It's really a nightmare for your release management systems. And then not only that, creating a highly available system in this case may be a direct factor of cost. And the only way to do it is by adding more servers or hardware capacity to the existing architecture. So let's take a look at an end-to-end architecture to modernize this. If you have your monolith application on-prem, you can choose to host it on Amazon EC2 compute instance, or you can deploy it as a container image on Amazon Elastic Container Service. You see, Amazon ECS eliminates the need for you to install and operate your own container orchestration software, manage and scale a cluster or virtual machines, or even schedule containers on those VMs. You would also want to employ an application load balancer, like the AWS Elastic Load Balancer, to act as a dispatcher between your monolith and microservices as you iterate over time. You would host your MySQL database to a managed database like Amazon RDS, MySQL, or MariaDB. Now, these are managed database services on AWS that you can stand up with a click of a button and provide a failover capability across multiple availability zones. At Amazon, we talk about the 5 pillars of a well-architected solution when we assess these solutions in the cloud. The proposed architecture shows strengths for each of these areas. So make sure you read them. Once you have a working model of your monolith running in the cloud, we begin the fun part. There are a few school of thoughts in how you can break down your monolith into microservices. One way to approach this problem statement is to look at the monolith at a very, very high level and to identify all business functions that it serves. Now, on a formal note, for extremely large-scale complex applications, this exercise falls into something we call domain-driven design pattern, before we can even go in and apply the cloud Strangler pattern for decomposition. Let's say in our example, we may break down the monolith into 4 functions: vendor management, customer management, content management, and employee management. Therefore, our first iteration will break down the monolith into 4 discrete microservices. Now, please note this is a highly simplified architecture for the sake of conceptual simplicity. In your next iteration cycle, you can break down each of these modules into its own subset of functions based on principles of autonomy and independence. Of course, there are other ways to break down this monolith. You can break them down by technical content or technical domain, client groups that serve a specialized set of functions, etc. Once you have this strategy in mind, you can start to refactor parts of your monolith one function at a time. To deploy this newly factored microservice side by side with your monolith, you would leverage an application load balancer like the AWS Elastic Load Balancer and create target groups for routing calls. You can also take advantage of separating data domains associated with microservices to be served by purpose-built databases. For example, you may want to use user management module to connect to a fast NoSQL type database like MongoDB or DynamoDB for user session management. Once you have all the new services carved out of your monolith, the monolith becomes an obsolete endpoint in your routing, and you should be able to successfully terminate it. All right, so it's demo time. Let's take a quick look at how you would build this using AWS services. We're going to first identify what our app structure or application structure looks like. So bear with me, but we are going to look into a IDE tool that I've chosen, which is Atom. I want you to pay attention to a containerized solution for this legacy application that I've built. This is a Node.js application, by the way, and I've got a no container type application that basically could run on a standalone laptop or a server. There's another one that I've built that's called containerized, which basically has the same set of services. And let's take a quick look at this server.js file, and I'll show you. Basically, this is still a legacy monolith application. For sake of simplicity, I only have a few number of APIs that I've defined. Now, your legacy applications are going to be massive, complex in nature. So certainly, this is just a simplistic overview of what it may look like. So we've got customers, we've got content, we've got vendors, and we've got employee modules in here, but they're all, as you can see, in this one big server file. Now, we deploy this application as a whole, and anytime we need to add a new functionality to, let's say, employees or vendors, we will be we will be basically retesting the entire application. We may potentially, through any kind of errors or complexity, break the entire application and may not be able to reach any of the endpoints here from a legacy standpoint. So again, the structure is very, very monolithic in nature. And then in order to be mindful of time, what I've done is changed or created microservices associated with, refactored this monolith to create microservices on my laptop. So mind it, I don't have all of this deployed to a production environment, but I do have them as standalone microservices and refactored code ready to go. So, you could see the customers folder, employees folder, vendors folder, so on and so forth. I also want you to take a quick note at the Docker file that we will be using in order to Dockerize this particular microservice called employees today and deploy it to a ECS cluster. And all it really reads is it needs, it's using Alpine 7.10 for Node. It's an older microservice, it's an older Node version, but this is what I had already created a while ago. And then we're exposing it at port 3000 and basically just executing the server.js file. So that's what it looks like. We're also installing Node, as you can see through the Docker file itself. So let's get going. I want to just make sure that you understand that when we start with our our deployment, that we have a few things that are taken care of. One, we want to make sure that we have AWS CLI installed and Docker installed on our local machine. And that's because when you're going to build these images, you will be using the CLI for Docker, as well as when we are deploying to the cluster, we'll be using AWS CLI as well. We've also, let me just get to the AWS console. What we have is a management console that I've already created. Okay, so this is my console. We're going to go ahead and look at the ECR, which is your Elastic Container Registry. This is where we're going to actually store your Docker images on this registry. And then we're going to take a quick look at the cluster where we're going to be hosting your application. So this is the ECS cluster. What you're looking at is a couple services that are already deployed. We will also be looking at the load balancer that we will be adding to the front of it. And let me just go ahead and make sure that we're on the right page. Just want to make sure we're looking at the right load balancer. We have a DNS already created for this particular load balancer. And then it's listening on port 80. And then default forwarding is to the legacy target group. This target group is now associated with the ECS cluster, and we've already deployed the legacy demo application on the cluster. In fact, I've gone ahead and deployed 3 more microservices that I carved out of legacy, which are customers, content, and vendor, and deployed them as services on the cluster itself. I want to show you a quick UI page that I have developed so that you can see it in a nice formatted way. But what you're looking at is the legacy portal right now, which is basically that one giant server.js file that hosts all the API calls to all these modules here. The idea is to actually break down these modules into its own independent services. And because I've gone ahead and deployed some of them, they may look like a different interface. You may have, nice tree diagrams or charts that you may want to create. But basically, I've just really created 3 UI pages hosted these services already on the cluster. And then we also are now going to go ahead and carve out that last module, which is the employee management modules on this particular service. Now, currently there's nothing going in here. So we'll be hosting it shortly. All right, so let me see if I can just go ahead and start our start building our Docker image here. And so the first thing you want to do is to just make sure once you have Docker installed, you're able to log into Docker, especially the image registry. And if we haven't really looked at that, we've got repositories that we've created associated with each of these modules and the legacy monolith application as well. If you look at that, there is a image version that's available. I've created repositories for each one of them. For the employees repository, I don't have any images. We're going to actually build one and we're going to deploy it. So let's go for it. One, we have to make sure that we are situated in the right folders where you have your Docker file. So I'm just going to issue a command, just make sure that you have your Docker file right here in your path. And then we just call the Docker build command. So let me go ahead and call this. What it does is it builds a local image on your laptop or your machine where you're running this from. Once you have the image built, what you want to do is to see if you can actually tag it to the repository where it should be loaded to. So that goes with the Docker tag command. I only have tagged it. It's still only tagged and still sitting as this particular path on your local machine. To push it to the actual repository, I would use the Docker push command. And that should really start pushing your image to the ECR. Okay, let's go back and check this on the ECR. We don't have an image. I'm going to go ahead and refresh this, and there should be a version 1 image that is built. It is as simple as that. You build, you tag, and you push your image to a repository of your choice. In our case, we're using the Amazon Elastic Container repository, registry under the employees repository. So we're good with that. The next thing that we want to do is to create a service on the container orchestrator, the ECS cluster. It should be called out as employee demo. But prior to doing that, what we do need is a routing mechanism that is created so that we can route our API calls to the new employee module that we will be running on ECS. And so I'm going to go ahead and show you how the routing is being set up. So again, currently the load balancer is listening on port 80. You could have 443, whatever you need. And then the default routing is always forwarded to legacy. But if there is any URIs in the path for the calls which relate to /service/content/customers/service/vendors, then we have separate target groups that basically will then route that call to these standalone microservices that are also running on your ECS. So what we want to do is to just create one more route here. And so I'm going to go ahead and add one more rule and make sure that I have a path for my employees module. So I will say /service/employees and then add an action forward to, and I've already pre-created a target group called employees for the sake of this demo itself. Once this is done, you have a routing mechanism to for your API calls to move to different modules that are running on ECS or wherever they're running in your production environment, separate from legacy calls. And please bear in mind the order in which these are called are also important. Legacy needs to be called as a default. So anything else, it needs to be interrogated and investigated in terms of URI. And if it falls within a rule, then we will potentially route it first to these microservices. And anything else that doesn't show up as a microservices, then route it to legacy. All right, so we're good. We're going to go back to our command prompt, and I would just want to show you a quick file that we're going to be using. It's called service.json. We've just created a service template. This is basically the definition for how we want the service to be created. It calls out for a specific target group that we've already created called employees. It also is set to be deployed on the TechFest demo cluster, which is the demo cluster that I've created for this particular session. And then obviously you've got the service name. It also calls out explicitly for the container port. So having done that, let's go ahead and create a new service on ECS using this particular file. All right, so it's on its way. And it looks like it's created a new service. So let's go back and check on our ECS console and just make sure that, so we've got 4 services running, including the legacy and the 3 microservices. We are going to create a 4th microservice or the 5th service on this particular cluster, employees demo. It's right here. It's using a task definition, which is basically a template for providing details on where the image is going to be pulled from and what the CPU memory allocation, some of the things that are needed in order to run the container itself. So we've got this all set up. Let's go to Postman and take a quick look. We'll test this. So I've got already Postman set up, and I'm actually just calling this particular DNS for the load balancer /service/employees. I'm going to try and see if we can actually just hit this. Again, it looks like it's working just fine, but I think the test comes when we go to the UI, where we know that the table was not loaded. So again, this is my employees microservice page or tab that I've created as part of the demo. And then if I just go ahead and reload this table data, it's actually loaded quite well. So it looks like now I've really broken down my monolith into all these 4 modules. And remember, we can further break this down into sub-modules or sub-functions as we iterate over time to optimize your architecture. But for now, we broke it down into 4 things. So essentially what we've done is really created your legacy, made your legacy obsolete. And then, so in this case, really what I want is I don't want anybody to get here by any chance, because all my new services are going to be living here. Any changes that go into these modules are going to go into these 4 services on ECS and nothing going into legacy. So the easiest thing you can do is you can choke it up at the load balancer level. And so what I'm going to do is to just go ahead and edit my forward to legacy. And prior to that, let me just show you this real quick on the target group console page. What I've done is I've created a target group called drop traffic. And what I've done is I've created it, but it's really not associated with any load balancers. It's basically a dead zone that I've created where if a request comes to the ELB and is routed to drop traffic, it goes nowhere. And so through that mechanism, I'm going to go ahead and just edit this, edit my forwarding to now drop traffic. And I'll go ahead and check this, update my load balancer routing rules, and then go back and actually, let's just go to the Postman real quick. It takes a few minutes, so I want to just make sure that it says service temporarily unavailable. Let's go to our UI page because this is a real test. So I've choked it up. Let's try to reload these tables. And now one at a time, it will show you that basically your legacy is not able to serve any more of the functions. So this is great because now all I need to do is to make a quick change to the UI and remove this tab. And now I can actually live as 4 different applications or microservices really in terms of the breakdown of this particular legacy monolith. So that's how you do it really essentially. That's what a Strangler pattern suggests. Again, this is highly simplified. In your case, you will be looking at complex systems, but essentially the idea is the same here. So let's go back to the demo. Sorry, the presentation. So I'm going to go ahead and all right, so we're here into DevOps best practices page, and we are now going to go ahead and look at the last slide for today's session. So far we talked about a conceptual approach in decomposition using Cloud Strangler pattern, and we followed it by an implementation strategy that I just showed you in AWS. Now, to enable and sustain this new shift in microservices architecture, we introduced DevOps best practices. Please note that DevOps is more a cultural change within your organization rather than an implementation strategy or methodology. Unless you have the former, most often the latter will fail. When we talk about DevOps best practices at Amazon, we talk about 3 laws that govern it. First, break things down. Compartmentalize your applications based on business or functional drivers and then apply scale to them. Second, teams are autonomous businesses. We talk about the 2-pizza team all the time here at Amazon when it comes to governing microservices architecture. And then third, you want to automate everything. What should you automate? Your organizational governance processes and shared services architecture. For example, your SSO login, your config management, governance at scale. You also want to use infrastructure as code. Leverage cloud formation templates or CDK on AWS. Use Terraform, Ansible, Chef, Puppet, whatever your skill set is. You want to automate your workload deployment, and we just looked at it using CI/CD pipelines. Finally, set up and auto monitoring and auto remediation triggers. Use observability tools like Prometheus, Grafana, CloudWatch, EventBridge, X-Ray, CloudTrail, name it, or you own your own tool set. But certainly make sure you have an automated monitoring and auto remediation process in place. Now, let's take a quick look at this architecture diagram and how we can develop pipelines natively on AWS to support this. In this particular diagram, we're showing Amazon Elastic Container Service natively integrating with AWS Code Commit, AWS Code Build, and AWS Code Deploy, and how it fits in our main solution architecture diagram. You can use AWS Code Commit as a fully managed source control service, or you can use any Git-based repository. Leverage AWS Code Build, a managed continuous integration service to compile source code, run your tests, and produce container images ready for deployment. Now, alternatively, you can always use any other CI tool such as Jenkins or Bamboo, whatever you may like. And then one of the advantages of using AWS native continuous deployment service like Code Deploy, especially with this particular architecture, is that it integrates well with ECS in our architecture. It also allows for an easy setup of blue-green or canary style deployment when you want to introduce change slowly in your production environment. Finally, a word of wisdom from me. Although you may find this change overwhelming, I suggest you start small. DevOps is an organizational change. Embrace it. Be patient with it. Over time, you'll get it. If you have any questions, you guys, please feel free to reach out to me via my LinkedIn handle. I hope you have a great rest of the day. Enjoy DockerCon 2022, and thank you.